Welcome to Daily Papers, the podcast where we break down fascinating new research. Today, we're diving into the world of artificial intelligence and software development. AI coding assistants like GitHub Copilot feel almost magical. They can write code in seconds, fix bugs, and speed up a developer's workflow immensely.
It really does feel like a superpower. You describe what you want, and poof, the AI generates the code. It often looks perfect. It compiles, which means the computer understands it, and it can even pass some basic tests. But there's a hidden problem, and it's a big one. The code might work fine by itself, but when you plug it into a larger, real-world software project, everything can fall apart.
And that's the focus of a new paper from Kennesaw State University called The Patchwork Problem in LLM-Generated Code. The authors call it the patchwork problem because it's like making a quilt. An AI might give you a perfectly beautiful, well-stitched patch, but when you try to sew it into the rest of the quilt, you realize it's the wrong size, the wrong color, or the pattern just doesn't line up.
That's a great analogy. The patch is fine in isolation, but it doesn't fit with the whole. The paper gives some concrete examples. Imagine an AI generates a new page for a website. This page needs to access a specific setting, like a secret key to connect to a database. But the AI just invents a name for that key. The code itself is syntactically correct, but the project has no idea what that key is, so the whole thing will crash when it runs.
Or another example, the AI writes code that tries to import a software library, a kind of pre-packaged set of tools. But it completely hallucinates the name of the library. It's trying to use a tool that doesn't even exist. The code looks plausible, but it's referencing a ghost.
So you might be thinking, don't programmers have tools to catch these kinds of errors? And they do. They have things called type checkers and linters, which are like sophisticated grammar and spell checkers for code. They also have automated tests that check if features work as expected.
But here's the scary part. The paper shows that these standard tools, this safety net that developers rely on every single day, almost always miss these patchwork problems. They check if the individual patch is okay, but they don't check if it fits the quilt. They can tell you a word is spelled correctly, but not if it's the right word for the sentence. This creates a huge blind spot where broken code can slip right into production systems.
So to tackle this, the researchers first decided to classify the problem. They came up with a taxonomy, which is just a fancy word for a classification system, of 8 different types of these structural failures. We don't have to go through all of them, but a few are really interesting because they're so specific to how AIs work.
My favorite is dependency hallucination. This is exactly what we just mentioned. The AI confidently writes code that uses a software package that doesn't exist anywhere. It just made it up. It sounds right, it looks like a real package name, but it's a complete fabrication.
Another big one is called build and configuration incoherence. This happens when the AI-generated code assumes the project is set up in a certain way, when it's actually not. For example, it might write code that relies on an environment variable. Think of it as a post-it note for the server with an important password on it, but it never mentions that this post-it note is needed. The code is just waiting for a value that will never arrive.
Or another example, the AI writes code that tries to import a software library, a kind of pre-packaged set of tools. But it completely hallucinates the name of the library. It's trying to use a tool that doesn't even exist. The code looks plausible, but it's referencing a ghost.
So you might be thinking, don't programmers have tools to catch these kinds of errors? And they do. They have things called type checkers and linters, which are like sophisticated grammar and spell checkers for code. They also have automated tests that check if features work as expected.
But here's the scary part. The paper shows that these standard tools, this safety net that developers rely on every single day, almost always miss these patchwork problems. They check if the individual patch is okay, but they don't check if it fits the quilt. They can tell you a word is spelled correctly, but not if it's the right word for the sentence. This creates a huge blind spot where broken code can slip right into production systems.
So after identifying these problems, the researchers built a tool to find them. They created what they call a hybrid verification framework. It's hybrid because it's a clever mix of old and new. It uses the existing, mature tools for the simple stuff they're good at, but then adds a new layer of custom-built detectors designed specifically to find these patchwork errors that span across the entire project.
It's like having the regular building security guard who checks IDs at the door, but also bringing in a master detective. The detective isn't just looking at one room, they're looking at the blueprints of the whole building, checking how all the rooms connect, making sure the plumbing goes to the right places, and that a new wall hasn't blocked a fire exit.
And when they put their new bug detector to the test, the results were staggering. They had two of the most advanced AI models, GPT-4 and Claude 3.5, generate code for a bunch of real-world software projects. Their framework found 67 of these deep structural failures.
Okay, so 67 failures. But here's the kicker. They then ran the standard tools, the type checkers, the tests, the security scanners, against the same code. How many of those 67 failures do you think the standard tools caught?
I'm guessing not many.
They caught 2. Just 2. That means 65 of these serious branch-breaking bugs, or 97%, were completely invisible to the tools that millions of developers use every day. That broken code would have been approved and deployed, only to cause mysterious crashes and bugs later.
Wow, that is a massive blind spot. The paper also found something else really fascinating. Different AIs make different kinds of mistakes. They found that GPT-4 was more likely to create errors where two different files failed to communicate correctly. On the other hand, Claude was more prone to making up file paths or referencing resources that didn't exist.
Which means you can't just assume all AI coding tools have the same weaknesses. Switching from one model to another doesn't solve the problem, it just changes the kinds of problems you have to look for. And unsurprisingly, the more complex the task, especially tasks that require changing multiple files at once, the more likely these patchwork errors are to occur.
So what's the big takeaway here? AI coding assistants are incredibly powerful, but we can't blindly trust them. This paper proves that the patchwork problem is real and it's slipping through the cracks of our current quality checks.
Exactly. It's a wake-up call for the software industry. As we use more and more AI-generated code, we need better tools to ensure that code is not just correct in a vacuum, but that it actually fits coherently into the larger project. We need to check not just the patch, but the entire quilt.
A fantastic look at the growing pains of a new technology, and a great blueprint for how to solve them.
That's all the time we have for today. Thanks for tuning in to Daily Papers.